welcome, welcome. You guys are already starting on reviewing. Yeah. Yeah, we can do that for sure. Yesterday, you guys asked for melting point and density, so that's what I've got prepared. But we can also do some physical and chemical changes. All right. I've got a lot of review in here, not just what you guys asked about yesterday. Like a GIM kit? No. Okay, let's hit present. All right, so review and cram day. So this one, you guys asked about melting point and density. Okay, so instead of using the arrows, I thought this might be a little bit more helpful to tell you guys how in the world this works. Okay, so I know it's a little bit dark for carbon here. Let me see how I can annotate this. Let's go. A bit more. Okay, so for carbon and then down here with tungsten and molybdenum and everything like that, I know it's hard to see, but the idea is that for melting point, right, the general trend is that it increases. The darker the color, the higher the melting point. Okay, so is tin going to have a higher or lower melting point than palladium? It's going to have a lower one. Okay, because again, the closer you are to this area of our periodic table, again, this is just a trend because I mean, look at carbon up here. Carbon's going crazy. Okay, but the closer we get to this area of the periodic table, the higher our melting point is going to be. Okay, so what I want you guys to do, pull out your periodic tables that you guys annotated, that you guys colored on, however you want to say it. Yeah, and that's an okay one too. Okay, but make sure that you know for melting point, it's a general trend towards the center of the periodic table. Okay, and that's what those arrows were trying to talk about. Arrows are a little tricky. This might help you a little bit more. Okay, so pull those out and make it so that when you look at your arrows, maybe you add like a target or something. Make sure that you understand what those arrows mean so that when you're on the test tomorrow, you know exactly what's going on. And so if I give you guys something like this, if I give you a lot of different pairs of elements, you can figure out which one's got the higher melting point. Okay, so work in your partner groups, turn and talk, figure out which ones in each pair have the higher melting point using your periodic table. And if you're finding that you don't remember the symbols for these, this is really good practice for tomorrow. Figure out how to remember those. Don tuned me out or finished with this. Okay. So let's go through this pair really quick. I'm going to grab a seat because I don't feel like walking all over the place today. So between tungsten and mercury, which one had the higher melting point? Tungsten. Okay, why? Closest to manganese, it's closest to the center of the periodic table. What's another way that we can look at it if we didn't know what the trend was? Mercury is a liquid. Why does that help us? We forgot. That's okay. Okay, anyone else have any ideas on why mercury being a liquid would help us remember, you know, the trend or recognize that tungsten has a higher melting point? Yeah, so if mercury is a liquid at room temperature and tungsten is a solid, that means it takes what to get tungsten to be a liquid? More heat, yeah. So we have to raise the temperature to get tungsten to a liquid. Mercury is already a liquid, so it's good to go. Okay, and then what about aluminum versus molybdenum? Or molybdenum, however you want to say it. All right, guys, raise your hand for aluminum. Okay, raise your hand for molybdenum. Awesome. Okay, again, why is molybdenum going to be a higher melting point? So it's closer to the center. All right. Iodine versus chlorine. Aubrey, what'd you get? Okay. What state are the two? Are they? What does your periodic table say? You guys have your periodic tables to use on the test tomorrow. So what state is iodine? What state is chlorine? It's a gas. Chlorine is a gas. Okay. In the halogens, you guys should have colored chlorine the same color you had for hydrogen and helium and nitrogen, oxygen, fluorine. If we look at our periodic table on the wall, guys, on our right, chlorine is red. Okay, chlorine is red, Cl. C is copper. Oh, Cu, yeah. Okay, so chlorine, we're looking at chlorine is a gas. What state can we see iodine is? Is it colored in on our periodic table? No, okay, so what does that tell us, Aubrey? What is it? What state is iodine going to be? It's a lovely question. It's a lovely question. Okay, how many states of matter do we have, guys? 3. What are they? Solid, liquid, gas. Which states did we label on our periodic table? We labeled gas. What else did we label? We labeled liquid. So if we've labeled gas and liquid, no, hang on. If we labeled solid, or if we labeled liquid and we labeled gas, what does that have to make anything that isn't labeled solid or liquid? Earth. Oh, I'm getting myself turned around here. It's all good. It breaks up the tension. What do you do? Put Aggie for silver? Okay. So if we've labeled something on our periodic table as a liquid, and we've labeled some things as gas, what does that make everything that's not labeled? A solid. Okay, so is iodine labeled as a liquid? No. Is it labeled as a gas? No. So what is it? It's a solid. Okay, if we didn't label it as a liquid or a gas, it's automatically going to be a solid.
Okay, so I have a question regarding that.
And I have an answer. Go.
So, with the cleaning agent iodine or whatever that is.
Oh, you mean like in hospitals, right?
Yeah.
Yeah.
So, but that's a liquid, right?
Yeah, iodine is weird. So the iodine that they use in hospitals is a liquid. Okay, but I don't,
But it
Mr.
wouldn't
Davidson, remind me, I don't think, I was gonna say, I don't think it's pure iodine. I think it's bonded to something else. So it's kind of like when we say, oh, go ahead and put chlorine in your pool. You're not putting elemental chlorine in your pool. You're putting in like some chlorine and oxygen compound. Okay, it's not Cl2 that you put in your pool to clean it up. You can just leave them on the bench in the back. Thank you. But yeah, so when we say iodine, right, it's awesome to start thinking about, okay, I've seen that in the hospital or in a medical drama. Really good to have that context, but just remember that sometimes when we call things like chlorine or iodine or anything like that, it may not be elemental or it may not be the pure substance. We have nicknames for things in science, and we have nicknames for things in the rest of the world. Okay. All right, let's look at bromine or carbon. Which one had the higher one? Point to the left wall. Wait. Your right wall for carbon and left wall for bromine. What do we got? We got one person stretching. We got a couple people. All right, awesome. Yeah, carbon's going to have a higher melting point. Again, if we don't use the trend, how can we tell that carbon has a higher melting point? Because bromine's already a liquid and carbon's a solid, right? Okay, what about silicon versus neon? All right, point to which wall it's on. Okay, so what state of matter is silicon in?
solid.
It's a solid. Okay, what about neon? It's a gas. Okay, so Zarek, which one is going to have a higher melting point? Silicon. Why? Solid at room temperature, neon's a gas already. Nice. All right, and then last one, antimony versus iron. Iron's got a higher melting point. Why do you say so, Luke? Because of this, yeah, because of your guys' periodic tables. If you guys have drawn them correctly and you can use them correctly, you can answer any of these questions. Okay, and I can guarantee that most of these kinds of questions are going to be on the test tomorrow. Okay, how come? Did you say how come? Oh, how great. Okay, I was going to say how come because we got to make sure you know it. All right, do you think you guys are good on melting point? We spent enough time kind of reviewing that. Do you want to move on to density? If you want us to stop, tap the break, let's, let me know. But sounds like you guys are pretty good. You guys are gonna do great on the test tomorrow. Okay. So let's look at density. Going back a slide.
So this one, these are the family names.
Well, they're the family names. They could be period numbers. They could be.
So I mean, like one of the questions that I think is like, what is like the family name for copper?
Oh, so for the family name for copper is going to be transition metals. I think I may have missed that part of it on your guys's. Yeah. Okay. So really quick, what I want you guys to do, pull out, your periodic tables. Guys, they should already be out at this point, your periodic tables, because we're working on them. What I want you guys to do is with a pen or pencil, I want you to label this block here, this whole chunk, as the transition metals. Okay, so everything, from scandium scandium to zinc, right? Everything in between there, and then everything below it. Okay, all of that is the transition metals. Let's see if I can annotate. Here we go. Transition metal. Which ones? So it is everything under here. Yeah. Okay, so if it asks for the family name of copper or zinc or iron or gold or silver, anything in this block right here.
So that's including these on the side?
Yeah, so that is including scandium, yttrium, lanthanum and actinium. Those are hard ones to say.
And for like boron, aluminum, cobalt, what are we-
So yeah, so for those ones, okay, let's see. So if we've got boron, all right, let's remember we had Roman numerals. Hydrogen was column 1, column 2, and then we skipped the transition metals with our Roman numerals. Oh, you went to 3 and 4 and 5. Okay, so if I asked for the family name or family number of boron, what would I say? You'd say 3, right? Roman numeral 3. Okay, what if I asked for tin's family? What family is tin in? All right, talk with your neighbors I'm going to give you guys 30 seconds. Talk about which one tin is going to be in. Again, if you don't remember the names of the elements with their symbols, you're in a little bit of trouble because we got the test tomorrow. I don't know how much cramming you can do to work on memorizing 50 elements in one night, but you at least have the chance to. Okay, so talk with your partners. Okay, what is going to be the family name of tin? Guys, some of these, remember how we named that the column 1 was the alkali metal and like column 8 was the noble gases? Not all of them have names. I mean, you're right. You're right. Okay. Listen, there are names for these other ones, but I'll be honest, I hate them. Davidson hates them. Goddard hates them. And if you guys had to learn them, you would hate them too. Okay, so we do not test you on the names for the boron 1, the carbon 1, nitrogen, or oxygen. Okay, we don't test you on those because they suck. They're weird. And it's more for you guys to memorize. Okay, all this is hey, read the number that you guys wrote down on your periodic table. Okay, so it's much easier this way. I honestly don't remember because I don't like them. Okay. So that's what we're looking at here, guys. When I give you guys maybe a group number, if I say, okay, I'm looking at group 5, okay, and period 3, which one am I talking about? Really? Arsenic?
Sorry, no.
I heard it. Phosphorus. Okay, I heard P in the back, and then I heard phosphorus here. Okay, again, we will try to trick you guys on the test. Teachers are horrible that way. Okay, I'll tell you, for example, we'll give you, the symbol K. Okay, what is potassium? But we may also put bananas. Okay, some people are using bananas as a way to remember that potassium is in bananas. And yeah, it's weird, but it works for them. I don't question it. Okay, we might put bananas in there. We might put carbon with a K. Okay, yeah, we're jerks. Okay, we are going to try to trip you up. So for P, we'll probably put platinum and phosphorus and potassium and palladium and all of these other elements that start with the letter P. Okay, so you guys have to be smart, which you already are. Okay, but you have to really think about some of these things and make sure we're not trying to trick you. Okay. All right, let's go on to our, come on now. Let's try now. No. There we go. You were supposed to go away, Trent. All right. All right. So which of the elements had the lowest melting point? Let's just talk about period 3. Which one is period 3? When I say period, what am I referring to, guys? Rows. When I say period, I'm referring to rows. Okay, if you ever get tripped up on that, just look at the one on the wall. Okay, we've got periods going down the side of it. So every number on the side of the periodic table is a period. Okay, so period 3, what's the lowest melting point? So we were just talking about melting point. Lowest melting point, yeah, argon, why? Yeah, it's the farthest thing away, and we can tell that it's a gas, right? In period 3, there's only 2 gases, so we've got pretty much a 50-50 chance on that. Okay, then let's look at alkaline earth metals. Okay, which one's going to have the lowest melting point of alkaline earth metals? Beryllium, awesome. Okay, and then one more, what about, yeah. All right, what about period 5? We're looking at period 5. What's going to be the lowest melting point? Yeah, xenon or Xe. Okay, you don't need to know the names of these elements to know which one is going to have the highest or lowest melting point. Okay, and then remind me, why do we know it's xenon? Yeah, it's furthest away from the center and it's a gas. Okay, so you have 2 ways to kind of logic your way through these questions. Okay. All right, let's look at, come on, please keep working. All right, this is density, okay? So we said that density goes towards nickel, right, in the rows, go towards nickel and then down. Okay, this is what it visually it looks like. Okay, down here we have our densest elements. Okay, this is like, let me see if I can read them. Oh, I cannot remember. We've got like borium in here, BH. It's very boring. You know, lots of really super dense elements in here. Okay, so think of this as kind of like a mountain. Okay, the closer you get to the peak, you know, if you're looking, you know, at from a bird's eye view and you're watching this hiker, the closer the hiker gets to the peak, what happens to their elevation? It goes up as you're going closer to the mountain peak, mountain top. Okay, the higher up you're going. Okay, so imagine this area here is our mountain peak. Okay, the closer and closer we get to this mountain peak, the higher our density is going to be. Okay, and you can use that for your melting point too, right? The closer we get to this mountain peak, the higher our melting point is going to be. Okay, and of course, there's always exceptions. Okay, this is just the general trend. Okay, it's not strictly a rule. Okay, but if we're looking at density, right? If you want to, make sure on your periodic table, maybe write a little note that says, hey, around here, higher density. Okay, that's what I had to put just to keep track of it because I got a little turned around. Okay, so make sure you write something down to help yourself remember that. Okay, now let's do some practice. Anyone want this up for like 10 more seconds? Okay. Oh, you have a question. Awesome. I have an answer.
There, like under AU,
Mhm.
RG, but on our periodic table, it's just U.
Yeah, so that's a good point. On your guys' periodic table, do you have white spaces? Yeah. So at the time that the periodic table that you guys are using was made, we hadn't discovered, all of these ones. We hadn't discovered them. Okay. Or if we had, they were kind of theoretical and they weren't really official yet. So, and you can see this on the one on the wall, right? You've got the UUN and the UUT, all these U's. It was because we hadn't really discovered. We theorized them. We'd made them for like a split second in the lab. Okay, but they weren't official yet. In the last couple of years, we've had more and more of them become quote unquote official, and we've named them. Okay, so the UUQ and P and all of that stuff, it's the same elements. OG, oganesson, is the same thing as UUO on the one on our wall. Okay, it's just a different name. But it's still, the principles still stay the same. Okay, so like, here's a thought then. If we discovered another element, okay, I've discovered 119, okay, I would probably want to put it right here on our periodic table, right under FR, okay? Would that make it more or less dense, do you think, than FR? FR. If I discovered the element that sits just below FR, will that be more or less dense, Luke? Really?
No, because it's lower.
Because it's lower, okay? Our density trends downward, right? Maybe I discover an element down here that is the most dense of the periodic table. It will not ever get any denser, okay? So we can use the periodic table and these trends to predict characteristics. Okay, if I discover that for some reason, we missed an element. We completely missed one, and it's supposed to sit right here. Okay, would we say that its density is going to be more or less than helium? It's more, right? Because it's just ever so slightly closer to this part. Okay. So yeah, that's what's awesome about the periodic table. We can say, oh, I just predicted this element. I've discovered it. And you can say, you know what? I think I messed up here because it doesn't fit in the trends that we know. And historically speaking, that's actually happened. Someone discovered it, published all this data about it. Another scientist said, you know what? I think you're wrong. This is why. And without even ever actually seeing that element, the guy that corrected was the one that was right. So he did have an advantage because he made the thing, but he made the periodic table. So let's look at a couple of practice problems, okay? And then this will be the wrap up of the trends that you guys have done. Okay, so work with your partners again, all right? Turn and talk and figure out which one in each pair is going to be denser. Okay, so take about, a minute and a half. Okay, and just talk with your partner, talk with your neighbor, figure out, is rubidium going to be denser than tungsten? And use your periodic tables and use your partners too. You guys are getting better. I really appreciate it. Okay, how are we feeling on this one? We feel a little bit more solid. Ha 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 ha. Bad, really bad pun. We feeling a little bit better on our density and melting point trends? Okay, then let's get into a little bit of practice overall. Okay, come on now. All right, really quick, guys, how are we doing? Thumbs up for feeling better about the test so far. Okay, we're not done with review. It's not like I'm going to make you take it in the last 15 minutes of class. It'd be really rude. Okay, but we're feeling a bit better, right? What? Oh, you want to call phone for help? Help! I'm going to fail the test. No, you're not going to fail the test. You're going to be fine. Okay, it's going to be good. Okay, so what I want you guys to do, work with your partners. Okay, this is kind of a long question. Okay, read this question or read this situation. Okay, I'll read it aloud for you guys too. Okay, and then I want you guys to determine if one, this is how you would do it, and two, figure out why or why not this procedure worked. Okay, so let me read it. Cindy had a mixture of iron, carbon, sugar, sulfur, and wood shavings. To separate the components, she first added water to the mixture and picked out the carbon and wood shavings from the beaker since they floated. Then she filtered the mixture to separate the sugar out. Knowing that the final two components had different melting points, Cindy placed the beaker over a flame to melt the sulfur and pour it out. Do you think Cindy's method worked? Why or why not? Okay, this is going to take a couple minutes. So work with your partners, figure out, did this really work? Was she able to separate all the components?
No.
Well, and what I want you to do, if this did not work, figure out a way to improve it. Okay, I'm going to come around and I'm going to ask you guys some questions about this. Okay, why do you think this thing works better? Why did you think it not works better? Okay, I'm not saying you're wrong. I'm trying to figure out why you're thinking it, what you're thinking. Capiche? Okay, really quick. As always, if you do not have a partner right next to you, you're allowed to move to find a partner. It's wild, okay? Or talk to the people in front of you or behind.
Hey, what's up?
Okay, there we go. Thank you guys. Okay, if I say talk with someone, that's kind of required to have someone next to you. Okay, I know it's first hour. We don't like talking, but we're gonna at least attempt. All right, so this one really kind of tested you guys because what was the key thing that Cindy did to kind of ruin her results? She introduced fire, okay? And is fire a chemical or a physical change? It's going to be a chemical change. What happens when she puts the beaker of iron and sulfur over a flame and starts melting it? You get iron sulfide. We did that in the lab a couple weeks ago, remember? Okay, so we're going to pull from the stuff that we have done in class to help you guys with this test, okay? So now give me some thumbs up, some thumbs sideways, thumbs down. How are we feeling today about the test? Okay, well, we've got mostly thumbs up, a couple of to the sides. I'm not really seeing any thumbs down. I love it, guys. Okay, so continue making good decisions, okay? We want you guys to study, okay? Review all of our matching terms, review the element quiz. And as a reminder, guys, before you go, okay? We can retake those quizzes on Canvas. If there's like the elemental tail check that you want to do, if there's any of the other quizzes, you can redo those because those are the questions on the test. All right, coming over.